Welcome to the channel. Today we will talk about an aircraft that is a further development of the famous MiG-15, the legendary MiG-17 fighter jet. How did it come about? What were its capabilities, and why was it able to shoot down the more advanced F-4 Phantom fighter jets in Vietnam? In the late 1940s and early 1950s, the United States and its North Atlantic Treaty Organization allies were actively preparing for a new world war, and the Soviet Union was forced to take vigorous measures to create means of defending the country from air attacks. One of the main measures was the development of high-speed fighters with powerful on-board weapons capable of intercepting and destroying enemy bombers carrying thermonuclear weapons in any weather, day or night, before they reached their targets. The success of the MiG-15 allowed the Mikoyan and Gurevich Design Bureau to obtain carte blanche from the country's top leadership to further improve this aircraft. The Mikoyan Design Bureau began work on modernizing the MiG-15 and installing a new wing with a sweep angle of 45 degrees. The MiG-15 BIZ production aircraft with a VK-1 turbojet engine underwent further development. The modernized aircraft, known as the MiG-15 BIZ-45, also received a new designation, SI-01. Its most important difference from the original version was a significant 10 degrees increase in wing sweep. The improved fighter received a new wing of reduced thickness with a 45-degree sweep and a modified cross-section with 3 aerodynamic ridges, which improved the aircraft's flight characteristics. The rear part of the fuselage was lengthened by 900 millimeters. The brake flaps and keel were enlarged. A fuselage ridge and hydraulic aileron booster were installed. The horizontal tailplane was redesigned with a 45-degree sweep angle at the leading edge, and a fuselage fin was also installed. The fighter's armament remained the same as that of the MiG-15 bis. Work on the SI-1 continued at plant number 155 until July 1949, followed by several months of fine-tuning. The first flight, piloted by Viktor Nikolaevich Yuganov, took place on the 26th of July 1949. A month later, test pilot E.T. Ivaschenko joined the SI testing program. At the beginning of factory testing, it was established that the maximum speed of the SI-01 aircraft with an engine of the same thrust exceeded the speed of the MiG-15 bis by 40 kilometers per hour, and on 1st February of the same year, at an altitude of 2,200 meters, the aircraft reached a speed of 1,114 kilometers per hour, that is, exceeded the speed of sound. However, on March 20th, during another test flight, the SI-01 crashed. It took more than a year to determine the causes of the crash. Destruction of the elevators during stabilizer flutter. Eliminate these shortcomings and build the next aircraft, the SI-2. After all the modifications in April 1951, the aircraft was transferred for state testing at the Air Force Research Institute, which ended on August 8th. During the tests, it became clear that it significantly outperformed the serial MiG-15 in terms of speed and rate of climb, although it was slightly inferior in terms of horizontal maneuverability and takeoff and landing characteristics. However, in the early 1950s, these indicators were not significant. The main thing was to achieve maximum speed, especially when climbing, which reduced the time needed to intercept enemy bombers. In the final test report, the Commission noted, "The modified MiG-15 bis aircraft with a 45-degree wing sweep and new tail unit has an advantage over the serial MiG-15. The new frontline fighter was recommended for serial production and adoption into service. Already in September of the same year, 1951, it was launched into production under the designation MiG-17. During production, the design of this fighter was repeatedly refined, and subsequently, several combat modifications were built on the basis of the MiG-17. The MiG-17 is a single-seat frontline fighter. It can be used as a light dive bomber or ground attack aircraft. Its design features an all-metal single-engine cantilever mid-wing with swept wings and tail, and a 3-leg landing gear. The fuselage is a semi-monocoque of circular cross-section. It consists of two parts, the nose and the tail. The technological and operational joint is made at frame number 13. This design ensures convenient installation and removal of the engine. Air for the engine is supplied from the atmosphere through intake ducts running from the nose of the aircraft to the engine. The unregulated intake is common at the beginning, then diverges into two ducts that wrap around the pilot's cockpit. The front part of the fuselage houses the air intake device, an emergency full-pressure receiver, and an instrument compartment. At the bottom of the nose is an artillery mount, a niche for retracting the front landing gear, and at the top is a sealed ventilation-type pilot's cockpit. The cockpit is covered by a teardrop-shaped canopy consisting of a visor and a sliding rear section. The fixed visor of the canopy is equipped with 64 millimeters thick flat armored glass. The canopy is equipped with a liquid de-icer. To improve rearward visibility, there is a periscope on the sliding part of the canopy. The cockpit is equipped with an instrument panel, controls, and an ejection seat that allows for emergency evacuation of the aircraft at an altitude of at least 700 meters and a speed of no more than 700 kilometers per hour. To activate the ejection mechanism, the handles located on the seat rails must be pressed. Inside the tail section of the fuselage are two fuel tanks, an engine with an extension pipe, and some of the aircraft's electronic equipment. On the sides of the fuselage are two forward-opening brake flaps with a total area of 0.88 square meters and a deflection angle of 55 degrees. The brake flaps are controlled by a hydraulic system, and in the event of a pipeline failure, the flaps close under air pressure. Under the tail section of the fuselage, there is a small false keel to increase directional stability. The wing is mechanized with ailerons with internal aerodynamic compensation and flap flaps. The aileron deflection angle is plus or minus 18 degrees. A trimmer was installed on the left aileron. The flap flaps deflect to an angle of 20 degrees during takeoff and 60 degrees during landing. The wing is a double spar wing. Aerodynamic ridges are installed on the upper surface of the wing, 3 on each console. The wingspan is 9.6 meters, the area is 22.6 square meters, and the transverse V angle is minus 3 degrees. The aircraft is controlled using the elevator and ailerons, which are kinematically linked to the control stick, and the rudder, which is linked to the pedals. To reduce the effort required on the control stick, irreversible hydraulic boosters are installed in the roll and pitch channels. Elevator control is duplicated by cable wiring. The tail unit is of classic swept design. The vertical tail consists of a fin and rudder. The vertical and horizontal tail profiles are NACAM. The sweep angle of the vertical tail at the leading edge is 55 degrees. The rudder deflection angle is plus or minus 25 degrees. The horizontal tail includes a stabilizer and elevator. The stabilizer sweep is 45 degrees. The elevator deflection angle is plus 16 to minus 21 degrees. The landing gear is tricycle with a nose wheel, retractable in flight. The nose landing gear retracts into the fuselage in the direction of flight, and the main landing gear retracts into the wing in the direction of the aircraft's longitudinal axis. The main landing gear wheels are equipped with brakes. The landing gear is retracted and extended using a hydraulic system. Emergency landing gear extension is performed by a pneumatic system. The power plant, a VK1 turbojet engine, was located in the middle of the aircraft fuselage, and an extension pipe was laid inside the tail section to divert the gas jet behind the tail cut of the fuselage. The engine had a centrifugal compressor, a single-stage turbine, and 9 combustion chambers. The engine air intake was located in the nose of the aircraft and was divided into 2 channels to bypass the cockpit. The engine was cooled by air flowing between its walls and the fuselage. To access the engine for maintenance on the ground, the tail section of the fuselage was detached. Fuel was stored in 2 fuselage tanks. One tank was located immediately behind the pilot's cockpit, and the second 2-section tank was located behind the engine under the extension pipe. The total volume of the fuselage tanks was 1,412 liters. Later, some series of the aircraft were equipped with wing tanks with a capacity of 265 liters each. To increase the flight range, 2 drop tanks with a capacity of 400 liters each could be suspended under the wings. The drop tanks significantly limited the flight speed and permissible overload. Electrical equipment was powered by a 27-volt DC generator on the engine and a battery. Oxygen equipment. At high altitudes, an oxygen device and 4 oxygen cylinders with a total capacity of 8 liters were used. Later models of the fighter were equipped with anti-G suits and a compressed air supply system. Armor protection consists of 64 millimeters thick armored glass in the front windscreen, armor plating in front of the pilot's cabin, armored backrests, and armored headrests on the seats. Armament: 3 automatic cannons. One 37mm N37 cannon with 40 rounds of ammunition was mounted on the right side of the gun mount, and 2 23mm NR23 cannons with 80 rounds of ammunition per barrel were mounted on the left side of the gun mount. For maintenance and reloading of the cannons, the mounts, together with the ammunition boxes, were lowered down, providing free access. Bomb racks were mounted on the external underwing suspension nodes, on which 2 100 or 250-kilogram bombs were suspended. The armament also included a 7-round block of unguided rockets for striking ground targets. Bombing could be carried out from horizontal flight, dive, or climb. Let's talk about the main modifications of the aircraft MiG-17F. With a VK-1F afterburner engine, serial production began in late 1952. It was manufactured under license in Czechoslovakia and Hungary, and at several factories in the USSR until 1959. The installation of the VK-1F engine with an afterburner chamber on the MiG-17F increased its speed to 1,145 kilometers per hour. In terms of its capabilities, the MiG-17F is deservedly considered the best subsonic fighter in the world. It outperformed such aircraft as the F-86 Sabre, Hawker Hunter, and Dassault Mystère 4A. The MiG-17P and MiG-17PF, equipped with the RP-1 airborne radar, became the first mass-produced all-weather fighter interceptors to enter service with the Soviet Air Defense Forces. The MiG-17 fighter jet was in service in more than 40 countries, and in most of these countries, the MiG saw combat action. The MiG-17 fought actively in many local wars. It shot down reconnaissance aircraft over the Soviet Union. It was in service in China for many years. In Africa, from Nigeria to Ethiopia, the Middle East, from Syria to Yemen, and Afghanistan, it also served as a light attack aircraft. In Vietnam, the MiG-17 was often shot down by supersonic F-105 fighter bombers and even F-4s, aircraft several generations newer. The fact is that these U.S. strike aircraft often carried a large load of bombs on external pylons, which sharply reduced their maneuverability. The MiG-17s approached their targets against the ground, undetected by most early war radars. The MiG-17's engine left almost no smoke trail, and suddenly fired their cannons. The first air-to-air missiles on U.S. fighters were unreliable in close air combat, requiring lengthy preparation and a certain launch distance. So the MiG-17s were able to attack even formally better-armed enemy aircraft. The MiG-17 aircraft scored their first victory on April 4, 1965. On that day, 4 MiG-17Fs intercepted 8 U.S. Air Force F-105 strike aircraft in the skies over Tan Hoa and, opening fire with their cannons, shot down 2 of them. Since then, April 4th has been celebrated in Vietnam as Aviation Day. The first MiG-17 losses occurred on June 17, 1965. In aerial combat, 2 American F-4B aircraft that took off from the aircraft carrier Midway encountered 4 MiG-17F fighters south of Hanoi and shot down 2 of them. As recalled by the commander of the 8th Tactical Fighter Wing of the U.S. Air Force, Colonel Olds, who shot down 24 aircraft in World War II and another 4 in Vietnam. The MiG-17 could really pack a punch, believe me. Of course, you can argue as much as you like that the F-4 could reach speeds of over Mach 2, but when the aircraft is loaded to the brim with bombs, fuel tanks, and lots of other stuff, after all, we were flying to engage ground targets. You're hardly going to squeeze those 2+ Machs out of it. You fly at the speed at which the MiG-17 fights best, even though it is old. And if it catches up with you, watch out. It's a light and surprisingly agile aircraft. The F-4 simply can't keep up with it in turns. As good as the F-4 is in air combat, it can't compete with the MiG-17 if you fight the way MiGs fight, which is maneuverable air combat in the style of World War II. In 1972, two Vietnamese MiG-17, each carrying two 250-kilogram bombs, were able to attack the U.S. destroyer Higbee, hit its turret, and leave without losses, despite U.S. claims of a downed aircraft. For the first time since World War II, a U.S. ship was damaged by an air attack. A total of 8,085 MiG-17 fighters of various modifications were produced in the Soviet Union between 1951 and 1958. Interestingly, more MiG-17s were produced under license abroad, in Poland and China, than in their homeland, with around 11,000 aircraft produced compared to 8,085. At the same time, the MiG-17 was reliable, relatively easy to fly, and undemanding in terms of ground maintenance. That is why the MiG-17 became one of the most widely used fighter jets in the world. Friends, if you liked the video, please like and subscribe to the channel and write in the comments which aircraft you would like to learn more about next.